Let us consider some problems of planes where we are required to use either the side view or some auxiliary projection. It is given that a hexagonal lamina of side 40 millimeters, a hexagonal lamina of side 40 millimeters, a hexagonal lamina of side say 40 millimeters is resting on one side in HP, is resting on one side in HP such that that side is parallel to VP, that side is parallel to VP and 20 millimeters from VP and 20 millimeters from VP. The opposite side is in VP. The opposite side is in VP. Draw front view and top view. Draw front view and top view. Now in this case, when we start with the projections, we are required to initially start with taking a distance of 20 millimeters from XY, drawing some reference line on which we will be marking the distance of 40 millimeters. So that will be the side. In all other problems of projections of planes, we are not given the position of any plane as such. This is a problem where we are given the position of side of that particular plane. Normally it is given in the form of only angles. So here the side is given to us, and so we are required to start with that side, and that's why I don't have the center of the circle which encloses the hexagon. So I will have to find out that center by measuring 40 millimeters, and then from there I should be marking the points. So I got all the points of that hexagon here, easy to mark in a way. So I will have to consider in this case the hexagon with its side parallel to VP and 20 millimeters from VP. We cannot stick to our earlier discussion, that is line of rotation should be perpendicular to XY, because in this case I cannot take that line of rotation perpendicular to XY. It is given that the line, because it is the hexagonal lamina which is resting on side in HP, which is resting on side in HP, and that side is parallel to VP, obviously we cannot exactly consider the line of rotation perpendicular to XY, and for that reason we should be going for the side view of this hexagonal lamina. I am initially keeping the lamina on horizontal plane so that its front view will be a straight line on XY. So I will be having its front view on XY, and initially even the side view will be on XY. So I am first of all going for drawing the projections of that hexagonal plate, keeping it in HP, and so after naming we can see as how that lamina is appearing in the front view as well as in the side view. To obtain the side view, we will have to take the intersection of XY line with the vertical line that we have chosen and rotate it, and rotate the other points which we are getting from that hexagonal projection. And now if I name this particular plate, the hexagon, in the top view, let us name it Of course, leftmost point is always named as A, B, C, D, E and F. The front view, A point will be on XY, so this is A dash. Then we have B dash and F dash. We will have C dash and E dash, and finally point D dash. So this will be the line view of that plane, and in the side view this will be F dash, E dash, A dash, D dash, and then B dash and C dash. So here we have the line view of that particular lamina, this portion, and now we are supposed to keep this lamina. If you just try to imagine it, if we can make a rough sketch of what the problem is talking about, then in that case it will be a figure like this. If we just make a sketch of it, we are given that, so this is horizontal vertical plane and this is horizontal plane. The hexagon is initially kept on HP, and then we are going to rotate it about this side, so that after rotation the opposite side goes to VP and it will appear like this. It is rotated in this manner. So the hexagon will have one side in VP, one side in HP. If you can imagine it, it is the rotation. So if you see in the side view direction, it will be seen in this manner that the line view is rotated about this point. This is how that side view will appear. This is one line, another line. This is in VP, this is in HP. In the side view direction, it will appear in this manner. It is rotated like this. This was HP, this is VP. This is the consideration that we are required to use. Now with this consideration, if we are required to draw the problem, then we have already got the corresponding side view. And F dash E dash will be the point about which it should be rotated, and F dash E dash is actually representing the same line of rotation which should appear as a point. So in side view, now I am going to take the distance equal to the length of that line view, and I will be rotating it so that I will get the final position of point B dash C dash in the elevation. That is the side view, and the vertical line over here is obviously representing the vertical plane. We are talking about the side view, and also the points A dash and D dash, they will get rotated up to the line view, new position, and this will be point A dash as well as D dash. So once we get the side view, then we have got the heights of these points in the front view, and so we can mark them. So we have got the height of point B and C, height of point A and D, but to obtain those points in the top view, we are required to project them down. Of course, BC will remain on XY, and F dash E dash, so we already have. So now only this particular point A dash D dash that we are taking down, that should be rotated in the opposite direction, and then we should be drawing the path. This is how the construction is done. So remember that for side view, we were rotating these in this direction, the earlier points. Initially these points are rotated in this manner, and then this was the point which has been rotated in the opposite direction. Similarly, if you consider the side view, these points are rotated in this manner. Both these points are rotated in this manner, and then they are projected down. So we are projecting the points down, and then we are obtaining their paths in the top view. We are obtaining their paths in the top view. So now I get the new position for point B and C, which will be here itself. Point A and D, and F and E remain in their position. And so we can draw the top view of this hexagonal plate in this manner. So this will be the top view of that hexagonal plate. Point F and E remain in their position. This will be new position of point A. B has moved parallel to XY. Of course, A also has moved parallel to XY, and that XY happens to be the vertical plane, auxiliary vertical plane in this case, new XY we say. So these points will move up and take their new positions as B. This is going to be point B, this will be point C, and this will be point D. Let me name the original points as A1, B1, C1, D1 to avoid any confusion. So let this point be A1, this is B1, C1, D1, F and E remain in their position. This will be the final position of A, B, C, D and E. Similarly, this is A1 dash, B1 dash and F1 dash, C1 dash and E1 dash, and D1 dash. If we go to the side view, these names will be F1 dash, E1 dash, A1 dash, D dash, B1 dash and C1 dash. Now to obtain the front view, we will have to follow our usual policy of drawing the projectors. So this is projector through point D. This will be projector through point C and E. This will be projector through point B and F. And this will be projector through point A. And we also have the path. So we will get point A in this case on path of A dash and projector through A. So this will be point A dash. Point B dash will be here. Point B dash will be at this position. This will be point C dash. This will be D dash, and E dash and F dash, they will retain their positions. And so we are required to connect them. So we join them and we get the front view and the top view. This problem cannot be otherwise solved if we don't use the side view. Observe that FE line has its elevation on XY, that means FE belongs to HP, whereas B dash C dash has got its plan on XY, so BC line belongs to VP, which can be very well seen from the side view. In the side view we can clearly see as where are the points, like F and E, they are belonging to HP, whereas B and C are belonging to VP. And the projections are actually very simple and straightforward over here. The two hexagons, they will share one side, but it is not the common side. Actually the same line is indicating one front view and one top view. And that's how we complete the problem. What remains now is to give the dimension which can be easily given. One dimension so we have already shown. We are required to just show the side of the hexagon. In this case it is given to us as 40 millimeters. So this will be distance 40, and that will complete the entire job. In cases they might ask you to measure the angle made by the particular plane with HP as well as VP, and if we are required to find that angle made by the lamina with HP, then see that this will be the angle at which the lamina is inclined to HP. This is angle theta, and this is the angle at which the lamina is inclined to VP, that is angle phi. Of course, in this case theta plus phi will come out to be 90 degrees. So one of the typical problems which makes use of the side view to complete the solution. So we started with the hexagon in the top view. We have drawn the side view, which is a line view, front view, which is also a line view. In side view we have rotated the lamina about f dash e dash, and we have obtained the line view in the side view. Of course point a dash d dash is also rotated. That has been taken back and paths are drawn. Rotation in one view resulted in movement parallel to xy. This time it is a new xy line that is under consideration, that is a vertical plane, in this case auxiliary vertical plane, and then we obtain the 6 points, join them. Draw projectors, we already have the height, so we can join them to obtain the elevation. There is one line which is common to two hexagons, though it is as a line on the projection it is the same line, actually representing two different lines. Line on xy represents elevation of line FE, which is in HP, and it is the same line which is representing plan of line BC, which is in VP. You can always see that FE is parallel to VP, whereas BC is parallel to HP. So these are the two lines which are seen in true length. Consider another problem. It is given that a pentagonal lamina ABCDE of side 45 millimeters has side AB in HP, making 30 degrees with VP, has side AB in HP making 30 degrees with VP, whereas side BC is in VP, Draw projections. Now as we are given that AB is in HP and BC is in VP, and if we think of point B, it is being the point of line AB, it will be in HP, and is point of BC, and BC is in VP, so point B should be in VP also. Ultimately point B will be on XY line, and so we are required to initially consider the hexagon the pentagon with point B on XY line. So the side of the pentagon is given to us as 45 millimeters. So with one point on XY, we are required to draw pentagon, and that side should make 30 degrees angle. So measure 45 millimeters, and then this angle that we have drawn over here, this angle is 30 degrees. Now to complete the construction of the pentagon, we are required to measure the internal angle. We are required to measure the internal angle as 72 degrees. We are required to measure the internal angle not as 72, has 108 degrees, and external angle as 72. So let us first of all mark that internal angle from each of these 2 points as 108 degrees. So it will be 108 from one side and even 108 degrees in the opposite direction. 90, 100, this is going to be 108. So we are getting here the points for that pentagon. First of all, we have got the angles on which that side will lie, and then pentagon can be completed because we know that this side is 45. Being a regular pentagon, we will mark the 2 points at a distance equal to 45, and then we can very well get the 5th point using the compass rather than measuring the angle. So I got the points corresponding to the pentagon, and these points can now be connected. So we have placed the pentagon with one side in HP, making 30 degrees, and naming also is very typical in this case. This is point A1, B1, which is in HP, and B1, C1 should be in VP. Right now we are keeping it in HP. This is point D1 and point E1. So we have got the particular position of the pentagonal plate in HP, and now AB should remain in HP and the lamina should be rotated in such a manner that C point should go to VP. Now C point in plan going to XY line indicates that it is in VP, whereas for point A and B the elevation should be on XY. Observe that point B is in HP as well as VP, so this point itself is its elevation as well as plan. Now to move this point C to XY line, we are required to perform the rotation about AB, and AB should have been perpendicular to XY because it is the line of rotation. But as it is given at 30 degrees and we have fixed up the position, we cannot make AB perpendicular to XY. Rather than that, we will make XY perpendicular to AB, and for that reason we will be drawing another line which we will be naming it as XY line only, perpendicular to C. I have aligned it to this line. Perpendicular to that line, I am drawing one more line which is referred to as X1 Y1 line, which is a new XY line, and I will be projecting all the points of the pentagon onto that XY, which becomes the line view, which can be named also. We can name all the points over there. So even naming is possible. This will be point A1 dash, B1 dash. This will be point C1 dash, E1 dash, and this will be point D1 dash. So the naming is possible. Now as we are going to rotate this line view about A dash B dash, how long, by what angle we should be rotating it, it will depend on where do we want to place point C. Now as we are going to rotate about A dash B dash in this view, rotation in one view is movement parallel to xy in other, so point C will move parallel to xy, point D will move parallel to xy, and point E will move parallel to xy. This time it is new xy line, that is x1 y1. But we are given that point C is in VP, that means its final position will be on the original xy. Its final position will be on original xy, and that's why we can name that point as point C. And if C point is over here, its elevation should lie on this line. That will be the consideration. We have got the final position of point C on xy, on original xy, and now to obtain that position I should have rotated the line view so that C point will have its elevation on this line. So this will be C dash point, and then these two are to be connected and extended further. So connect these two and extend them further, on which we are required to mark the point D, on which we can mark point D. So this is point C dash D dash, this is point C dash, we have got point C dash, we get point E dash also at the same position, and this will be point D dash, and we can very well darken the line view of that lamina. This is how it should be inclined, and obviously this being the elevation, this will be angle made by the lamina with HP, that is angle theta. Now we have got the position of C dash through point C, which we have marked in the plan, but plan of point D is to be marked. So you draw projector, that is a line perpendicular to xy through point D dash, and the same line which we have drawn through C should be extended. So it was the consideration that rotation in one view is movement parallel to xy in the other, and as we have got the movement parallel to xy, like point E will be moving parallel to xy, new xy, point D will be moving parallel to xy, and point C, so we have already moved it parallel to xy to fix up its position. So I can obtain position, final position of point E. I got the final position of point D also, and point C, so we have already marked, and so we get the plan of this pentagonal lamina. To satisfy the conditions which are given to us in the problem. So we could complete the plan, and now what remains is to draw the elevation of this pentagonal plate, and to draw the elevation we should be drawing projectors perpendicular to original xy line. So this was our first xy line through which we will be drawing the projectors through all the 5 points. We are drawing the projectors through all the 5 points A, B, C, D, E, and their heights can be taken from the side view. Point A and B, they will be on xy, so this will be final point A dash, and this is final point B dash. Point C and E, their distance from HP is this much, so we can mark point E, so this will be E dash, and point C, this will be C dash, and for point D the distance is from x1 y1, we will be measuring the distance and marking it on the projector of D. So we get final position of point D dash, this was C dash, and this was B dash, and they should be now connected. We should be connecting these points to complete the elevation. Again, a problem which cannot be solved without the help of the auxiliary plane. This is called as the auxiliary vertical plane because it is seen as a line in the top view. This will complete our problem. What remains is the dimensioning part of it, which can be very easily completed. Actually, all the problems can be solved using the auxiliary planes, but it will be sometimes difficult to decide the visibility part, and hence we will prefer to use the rotation of the view technique only to complete the solution. So this is how the problem will appear. A complete solution. We have started with pentagon drawn at 30 degrees with one side 30 degrees. Point B being in HP as well as VP, draw it on XY. Then I had taken X1, Y1 parallel to line of rotation because I cannot place the lamina in that manner, and so rotation will be about A dash B dash, but rotation in this particular new view will result in movement parallel to new XY, and we know that point C should be in VP, in original VP, so we fix up the position of point C by drawing a line parallel to X1, Y1 through point C where it intersects the original XY. We get point C. So I have drawn the projector of point C, and then we have rotated distance A dash C dash, and the intersection has given me point C dash, which I have joined to A dash and extended to obtain point D dash. So D dash point has been through rotation, and then we have drawn the projectors through D dash, through C dash, so we already had the projector, and there were paths through plan. The respective intersections had given us the points, and once we get the 5 points, we join them in plan. We draw projectors which are lines perpendicular to XY, and the heights of these points from XY are actually the heights of the elevation points in the auxiliary view. So this was the distance of A dash C dash, which I had marked on the projector of C dash as well as projector of E dash, so point E. Similarly, this was the distance of D dash, which I had marked over here, and we could complete the projector. The two views of a triangular lamina. We are given the two views of the triangular lamina. For example, the view will be given to us. So we have a projector for point A, and it is given that point A is 20 above HP and 30 in front of VP. Then there is another projector which is at a distance of 40 millimeters from projector of A, on which we have point B at a distance of 10 millimeters from HP and 70 millimeters from VP, and from there at a distance of 30 millimeters we have one more projector on which we have a point which is 60 millimeters above HP and 15 millimeters in front of VP. So all the distances are given to us. So we can even show these distances in the final projections, which we are of course are required to show them, because the description of the figure could be either in the terms of wording or the description, the entire figure itself is given to us with the dimensions. So whatsoever is the case, we are required to show all the dimensions over here correctly as they were given to us. So we are given plan of that triangular lamina and also the elevation. So this is plan and this is the elevation. So this was point A, point B, point C. This is A dash, B dash and C dash. So we are given these points and also the distances. So all these distances are given to us. Like point A was given to us 20 millimeters above HP and it was 30 millimeters in front of VP. Point B was given to us as 10 millimeters above HP and it was as much as 70 millimeters. It was 70 millimeters in front of VP, whereas point C was given to us as 15 millimeters in front of VP and it was 60 millimeters above HP. So we are given the projections of a triangular lamina with all the dimensions given into it, and we are required to find out the true shape of this lamina. We are required to find the true shape of this lamina as well as the angle made by the lamina with HP and VP. Now for that purpose we should be having true length of some line on this triangular lamina. None of the edge is having any view parallel to XY, so none of the views is giving us the true length of any side of this triangular lamina. So let me first of all draw one line through A dash parallel to XY. So we get some point on side BD, BC, which I name it as say point D dash, and then transfer that point D dash on side BC in plan. So I get point D. See the construction. I am drawing line parallel to XY through point A dash and naming that particular line as A dash D dash, and that point D dash has been transferred down on side BC in plan, and that will be point D. Now obviously if we join AD in plan, this is going to be the true length, because elevation is parallel to XY. Elevation parallel to XY, in that case line will be parallel to HP and plan will give us the true length. So I got the true length of some line on that particular plane, and then we should be aligning the drafter to that line and stretching that line further, and then perpendicular to that line, we should be constructing an auxiliary vertical plane called as X1, Y1. We should be constructing an auxiliary vertical plane called as X1, Y1, and then we should be transferring all the points. We should be drawing projectors through point C as well as point A and D as well as point B. So we should be transferring or drawing the projectors through all the points of the plan, and then we should be transferring the distances from the elevation on the respective projector. Like point A was 20 millimeters above HP, so I will be marking point A dash over here on projector through A. Then point B was 10 millimeters above it, so I will be marking point B, which will be B dash here, as well as point C, which was 60 millimeters above, so point C dash can be marked. Now when you transfer the distances like this, then we had considered the auxiliary plane which is perpendicular to the true length. That means you are going to look along the true length, and when you look along the true length, observe that this particular pencil, if you look along its length, it is going to appear as a point. This is appearing as a point, and as it makes some angle, its length will be seen. Obviously, whenever you are going to look along the true length of some line like this, then it is going to appear as a point. And if we are looking in this particular direction where the line is appearing as a point, and then if we look perpendicular to it, then we can see its true length. So here we had true length, we are looking along the true length to obtain the point view of the line. Ultimately the plane will be seen as a line view, and you will observe that when we join these 3 points A dash, B dash and C dash, they will be lying on the same line. These points will be collinear points, and then this will become the angle made by the line. As this is elevation, this will become the angle made by the line with xy, that is angle made by the plane with HP, called as theta. So our aim is to find out the angle made by the plane with HP as well as VP. We got one of them. For the second one, that is to find out angle made by the line with VP, we are required to have a similar construction. Now I will be looking for true length in the elevation. For that, again through point E, I will be drawing one line parallel to XY and name that particular point as point E. This point E should be transferred to the elevation to obtain point E dash, and then we are required to join A dash E dash. So A dash E dash is the true length of line AE that we are drawing in plan, which is parallel to XY. So plan parallel to XY, elevation will give us true length. Now perpendicular to this true length, we should be having one more plane. We should be having one more plane, which is auxiliary inclined plane. Now we should be drawing one more plane, which is auxiliary inclined plane. Let us name it as x2, y2, so that line A dash E dash will be seen as point, and we are required to mark the other points also. So draw projectors through all the points of that triangular lamina, and then transfer the distances. Point A dash is at a distance of 30 millimeters. Point A, I suppose. Point A, plan point, is at a distance of 30 millimeters. So mark point A. Then point B was at a distance of 70 millimeters. So mark point B. And point C was at a distance of 15 millimeters. So mark point C. And then if you join these 3 points, again these 3 points will belong to one and the same line. So we get the line view of the lamina, this time in plan. And when the plane appears as line in plan, then the angle made by that line view, with xy will be the angle made by the lamina with vertical plane. So this is angle made by the lamina with vertical plane. In elevation, when you get true length and you look along that true length, you will be getting the point view of that line. This is point AE. So line A dash E dash will be seen as point. Ultimately the plane will be seen in line view. And line view making an angle with the XY line will give us angle made by the plane. This was plan. So in plan we can see angle made by the plane with VP. And now to obtain the true length, we are required to construct one more auxiliary view. And in this case, we will be taking XY line parallel to the line view that we have got. So we have got line view in plan. And then we are required to construct one more XY line, auxiliary line, which is parallel to the line view. That is X3, Y3. And we should be drawing projectors perpendicular to that. So from this particular line view, we are required to now draw projectors perpendicular to new XY, that is X3, Y3. Through all the points, there were 3 points. So we have transferred the projectors. Now we are required to transfer the distances. The policy is always, see, from this particular plan I am going for elevation. So go to the previous elevation, previous XY, measure the distance. So I am measuring the distance of point C dash, and from new XY transfer it on the respective projector. Similarly, for point A, take the distance of point A dash from previous XY, that is X2, Y2, and transfer it on the projector of A dash, and transfer it on the projector of A dash. And then finally take the distance of point B from previous XY, that is B dash from previous XY, and from new XY transfer the distance. And so we get in all 3 points. We get in all 3 points in this case. And those 3 points are to be connected to each other. So this was my point A dash, sorry, C dash. Then I have a point A dash, and I have point B dash. So if we connect these 3 points, then we get the true shape. Obviously when one view is line view, the other view, that is when you look perpendicular to that line view, you will be getting the true shape. And in this case, this A dash, B dash, C dash that I am getting over here will be the true shape of that triangular lamina. And our job was to get the true shape. Our job was to get the true shape as well as the angles made by the lamina with VP and that with HP. So in a way you find that this particular problem which we are drawing over here, this problem consists of several XY lines which are to be considered properly. Like we started with the line view, then we had drawn A dash D dash parallel to XY, we got point D. We have chosen a plane which is perpendicular to HP because it is seen as line in the plan. So this will be auxiliary vertical plane. An auxiliary vertical plane has been constructed which is perpendicular to the true length of AD. Ultimately it was plan and I will be getting the elevation. Angle made by the elevation with auxiliary vertical plane. Angle made by the elevation with auxiliary vertical plane will give me angle theta. Similarly, I had drawn AE parallel to XY, I got A dash E dash as true length, then I had considered one auxiliary plane which is perpendicular to the true length over there, and it will be the auxiliary inclined plane. Then I obtained the line view in plan, that will be angle made by the line with VP. So we got angle made by the line with VP. Once we get that particular angle and the true length and the line view of the plane, then we had taken another plane. This is again auxiliary plane. Now the sequence will be always transfer, like here it was auxiliary inclined plane, this will be auxiliary vertical plane, but need not be related to the original system. So it is again auxiliary plane which is taken parallel to the line view. Of course, I could have taken the auxiliary plane parallel to the previous line view also. Like I could have taken the auxiliary plane parallel to this line view, and then I could have drawn the projectors from here. I would have still got the true shape of that particular lamina, but this time it will have been in the plan. So the construction remains the same. Ultimately, this particular problem that we are solving is not following any typical path, or to determine the space required for solving such a problem will be the first and the most important point, because you are likely to go out of space at any time. So this is one case where we are given the top view and front view of some triangular lamina, and we are required to find the true shape as well as angle made by that particular lamina with HP as well as VP. We are required to find both the angles. The problem is to be solved by auxiliary plane. There is no other way of solving such a problem. So we are talking about all the problems of planes where we will be requiring the use of the auxiliary planes, without which the problem is unsolvable. Remember, this is one of the very important problems. Of course, to obtain the true shape, we could have obtained the true length of each of these lines separately. Find true length of AB, make this AB parallel to XY, A dash B dash will give you the true length. Make BC parallel to XY, make BC parallel to XY, you will get B dash C dash as true length. Make AC parallel to XY, you can get the true lengths, but then you won't get the angles, and that's why this problem is very important. Let us go for another case. This is how the entire problem will appear. We have plan, elevation, then again plan, again elevation. This was plan, this is elevation, this is angle theta, this was angle phi, this will be the true shape. So the entire problem, though not many lines or many projectors to be drawn, it is rather going in a haphazard manner. So we will proceed to the next problem of planes. Say, take down the problem. A circular lamina is cut into two pieces, and a hexagonal lamina is also cut into two pieces. A new lamina has been formed. Such that half of it is a semicircle. Half of it is a semicircle, whereas remaining half is the portion of hexagonal plate. Is a portion of hexagonal plate. Such a lamina is resting on one side of the hexagon, which is having a point common with the semicircle, on HP, such that the lamina is inclined at 45 degrees. The lamina is inclined at 45 degrees with HP. 45 degrees with HP. The side in HP makes an angle of 20 degrees with VP. Draw projections. Now observe that I have drawn the area which is more than a semicircle, because I know that the line of rotation in this case is the one which should be perpendicular to XY. First of all, it should be perpendicular to XY, and its point is common with the semicircular part. So this is the semicircle, it is starting over here, and then I require 3 more points to form that half of the hexagon, because this is how the lamina has been formed. And so the lamina will be having a shape like this. There will be 3 sides corresponding to that hexagon, and remaining will be the semicircle. And the line of rotation is taken perpendicular to XY. This is how the problem should start. So this side is A, B, C, D, and there could be some divisions of the circle as usual. So this circle also has to be divided into as many as 6 parts, which is one of the standard things. So we are required to divide it into 6 parts. That can be done by using the 30-60 set square as such, and we get the division. So this is 1 point. We will have 1 division over here. This is second division. Then you can have 1 more division over here. Circle should be ultimately divided into 6 parts. So these are 4, and this will be the 5th and 6th point. So this is how it should be drawn, and let us number these points as, say, 1, 2, 3, 4, 5. So the front view of this lamina will be on XY, because lamina is kept initially on the horizontal plane. So we have got all the points over there. and so it can be named elevation as A dash, B dash. This will be point 5 dash. This will be point 5 dash. Then we can name points C dash, 4 dash. This will be 3 dash. It will be D dash and 2 dash, and then 1 dash. So I obtain the line view. Then the lamina is making 50 degrees with HP. So mark an angle of 50 degrees at the line of rotation. So mark an angle of 50 degrees at the line of rotation. Angle with HP will be seen in the elevation. So draw a line at 50 degrees. Once you draw this line of 50 degrees, at 50 degrees, then all the points should be transferred on this particular, on this line which we have drawn at 50 degrees. So all the points should be transferred onto that line, starting with point 1 dash, then point D dash and 2 dash, then point 3 dash, then point C dash and 4 dash, and finally point 5 dash. So all the points should be transferred to the line view, which is rotated at 50 degrees. So the new line view that we get will be this one. Of course the naming remains the same. 1 dash, this is D dash, 2 dash, this will be 3 dash, this is C dash, 4 dash, and this will be 5 dash. And then after rotation, after the rotation, we are required to transfer all the points to the plan. So draw projectors through all these points. So this is projector through 1 dash, through D dash and 2 dash. This will be projector through 3 dash. This will be projector through C dash and 4 dash, and this is projector through 5 dash. Once we draw these projectors, all the points in plan will be moving parallel to XY. So this is path of C. This will be path of point D. This is path of point 1. This will be path of point 2. Then this will be path of point 3. This will be path of point 4, and this is going to be path of point 5. So draw all the paths, and then the respective path projector intersection will give us the points. So we obtain point 5 on the projector through 5 and path through 5. This is point 5. Point 4 will be obtained on projector through 4 dash and path of 4, whereas point C will appear on path through C and projector through C dash. Then point D will appear on projector through D, or projector through D dash and path of D. Point 1 will appear here. Point 2, then we have point 3, point 4 is already marked, and then these are to be connected. These are to be connected, the hexagonal part by straight line. The hexagonal part by straight line, and the remaining portion which forms the semicircle by a smooth curve. By a smooth curve. and this is how we get the new plan. Now this particular figure is to be lifted and should be drawn again, because this side which is in HP should make 20 degrees with VP. Side in HP should make 20 degrees with VP. Now in this case that rotation will be rather a complicated one, because the figure is pretty odd, there is no symmetry. And so what we propose over here is, instead of rotating the plan, let us rotate XY line itself. Let us rotate XY line itself so that it will make 20 degrees with AB. So let us draw a line at 20 degrees with AB. So I am marking 20 degrees with AB here. This line is making 20 degrees with AB, and I will be now taking the XY line parallel to this. I will be now taking the XY line parallel to this at some distance. So I am taking it here. A new XY line has been drawn, called as X1, Y1, such that the angle made by AB with XY will be 20 degrees. And then we should be transferring or drawing projectors for all the points, starting with point A, point B, then point C, then we have point D, then point 1, then point 2, then point 3, then we also have point number 4, then the new point 5. Here 2 and 5 are coinciding, and point A we have already drawn it. So we are required to draw projectors through all the points of the plan. And as we draw these projectors, then we are required to mark the points. A dash and B dash was on XY, so we get point A as well as point B. Then for point C, this is the distance of point C from XY, and so on projector of C, mark the point. This will be point C dash. Of course, same is the distance for point 4, so I can mark point 4 dash also. Then point D, its distance from XY is XY to D dash, and then on the projector through D, mark that distance. So point D has been transferred. Then let us go one by one. Point 1, this is the height, and 1 should be drawn on projector of 1. Point 2 is same as that of D, so point 2 can be marked. Point 3, its height from XY, take that height on the projector of 3, mark that height. Point 4 we have already marked, and finally point number 5. Point number 5, its height is to be transferred on the projector of 5. So we have transferred all the distances. And now we are required to connect them. So A to B, then it is B to C, that should be connected by a straight line. So this was my point A dash. Then this will be point B dash, this is C dash, and then point D, so this will be D dash. So these are the 3 sides of that half hexagon, and the remaining are the points. So point number 1, Then point number 2 dash, this will be 3 dash, 4 dash and 5 dash to be connected by a smooth curve. So it has to be connected by a smooth curve, and then we get the elevation. So the final views which represent the projections is this is the plan and this is the elevation, whereas the original one can be considered just as the construction part. So using auxiliary planes, the problem may appear to be a simpler one as compared to the problems which we have solved earlier. Of course, the old figure, that is the true shape, that should be faint, which we had unnecessarily drawn dark while explaining the shape of that lamina. So if by chance you have made it dark, then that should be made faint. It was just the construction to indicate as how that lamina is. So the original shape is just the construction, and the new shape, that should be the dark one. So what we darken are only the final plan and elevation. So only these two views, they should be dark. Plan and elevation. Actually this XY line is the final XY line and our projections are over. Again a pretty odd type of solution which we can see here, unnecessarily changing the directions. But we have avoided the time taken to redraw that particular shape. So some redrawing effort can be minimized, but then you should be very good at using the drafter, because the better use of drafter will give us the faster speed. Instead of rotating the view, it is a concept that XY line will be rotated. Here AB was showing us the true length, and so we can rotate XY line by the true angle. Otherwise we might be required to find the apparent angle also, and XY could be rotated at that apparent angle. The solution from front will appear like this. Odd shaped lamina, half hexagon and semicircle, connected to each other, resting on the side which is having a common point with the semicircle and hexagon. And so first the angle made by the lamina with HP is drawn. We got final plan, and then that side in HP should make 20 degrees. So instead of lifting this particular plan and drawing it at 20 degrees, we have rotated the XY line itself, and the distances of all the points, they are transferred from the previous elevation to obtain the new elevation. It is the same concept again. Go to the previous XY, previous view, take the distances and transfer. A solution by the auxiliary plane.